In this video, I want to take a look at products and quotients, so multiplication and division of complex numbers. And these operations can be performed with complex numbers in either the polar, trigonometric, and exponential forms, as well as rectangular. We already saw it in rectangular. However, they're much more convenient in polar, trigonometric, and exponential forms. So let's take a look at that. And then that will lead us to looking at powers and roots of complex numbers as well. One thing I want to note, and this is a must, addition and subtraction of complex numbers must be done in rectangular form. All right, so that's just something to keep in mind. You can only add and subtract when a complex number is in rectangular form. Now, let's take a look at some shortcuts though. When your complex number is in one of these other forms, polar, trigonometric, or exponential, multiplication and division becomes much more convenient. So let's take a look. Okay, now here are the formulas for them for multiplication of complex numbers in exponential, trigonometric, and polar forms. Now I said much more convenient, and these might look a little bit complicated at first, but trust me, it's not. So for example, just focus on the exponential form here. Let's put a box around that to keep us looking only at that part right there. Exponential form consists of r e to the j theta. All right, so that is r e to the, let's make it a little bit lower there, r e to the j theta, right? So notice that I've got just a subscript here. This is for complex number 1, subscript 1, and for the second one, subscript 2, that's all. So notice what's happening. I've got two complex numbers in exponential form. When we multiply them together, you multiply the r's, you keep the form of the complex number in exponential form, so it's still e to the j theta, keep the j, and you add the exponents. Really quite simple. In trigonometric form, now this one looks a little bit longer only because the trigonometric form is longer. It is r cos theta plus j sine theta. And we have two of them here being added together, or sorry, multiplied together. There's a multiplication going on right there. But notice the same thing. R1 and R2 are multiplied together. Keep the form of the complex number, cosine theta, we are adding them, plus j sine theta, and we are adding the theta 1 and theta 2 in that case. In polar form, which is r angle theta, two of them being multiplied together, we do the exact same thing. Multiply the r's, add the angles. And you can see, once you start to practice that, you will see just how much more convenient that is. Here is an example of multiplication in the polar form. So we'll multiply the two complex numbers 20 at an angle of 52 degrees and 30 at an angle of 40 degrees. Following the formula, it says that we should multiply the two r values together, which are 20 and 30, and then we should add the two angles. So 20 at an angle of 52 degrees times 30 at an angle of 40 degrees equals 20 times 30 for the new r at an angle of 52 plus 40 for the new theta. So notice that it remains in the polar form, r angle theta. Multiply the r's, add the angles. And so this one becomes 20 times 30 for r, which is 600, at an angle of 52 plus 40, 92 degrees. One thing to note about the angle in your final result is it usually is expressed as an angle between 0 and 360 degrees. In some applications, it's expressed as a negative angle, like in the electrical. But it would be good practice to just express the angle as an angle between 0 and 360, which means if we get an angle greater than 360, we should express it as a coterminal angle between 0 and 360 degrees. For example, if theta turns out to be 400 degrees, then that angle is coterminal with, we would subtract a full 360 from it to bring it back around the circle, one full rotation, and end up with it being coterminal with 40 degrees. So this would be a better way to express the angle than the one that is greater than 360 degrees. Now, very similarly, we can perform division of complex numbers in exponential, trigonometric, and polar forms by doing a very similar process, except instead of multiplying the r's, we will divide the r values. r1 divided by r2. And instead of adding the angles, we will subtract. So theta 1 minus theta 2. And keeping the same form, this will be re to the j theta. And in trigonometric form, the answer will take the form r cos theta plus j sine theta. And in polar form, it will take the form of r at an angle of theta. So notice in each one, I've got a complex number in a trigonometric form here, another one in trigonometric form, and we are dividing the r's, subtracting the angles, so we should get the same angle in both of those positions. And then in polar form, r1 divided by theta, so r1 angle theta 1 divided by r2 angle theta 2 will turn into r1 over r2 and the angle theta 1 minus theta 2. So here's an example of division in the trigonometric form. Take note, it is trigonometric form because we have r angle cos theta plus j sine theta divided by the same form, r cos theta plus j sine theta. So what is it we need to do? Well, remember that we divide the r's, 3.2 divided by 1.5. We will keep it in the trigonometric form. This will be cosine of some angle. And the angle we do for division becomes 55 degrees minus 280 degrees plus j sine 55 degrees minus 280 degrees. And now, so the answer will look like 3.2 divided by 1.5. Let's say that's 2.13 cosine, and the angle is 50 minus 280, which is minus 225, plus j sine minus 225. Okay, now it's not, let me fix that bracket. It's not terrible to leave it as a negative angle, but let's put it as a coterminal angle between 0 and 360. So minus 225 is coterminal with, if we add a full 360 to that, we get 135. So this answer could also be expressed as 2.13 cosine 135 plus j sine 135. All right, that's multiplication and division in polar, trigonometric, and exponential form.